Welcome to Pratidhvani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my absolute delight to have my dear friend and colleague, Ashish Arora.
Thank you.
Ashish is an experimental condensed matter physicist working at the Indian Institute of Science Education and Research, Pune, in the Department of Physics. He is an assistant professor there and he's setting up a very interesting laboratory which actually brings together various different aspects of condensed matter, including optics, also as a strong element, where he does magneto-optics. One of the key elements, and which is very impressive element of Ashish Arora's work, is that he's not only an excellent scientist, but also he's deeply interested in science outreach activities and science outreach not only in English, but also in an Indian language and Indian languages. For example, Hindi and Punjabi. And he also has some excellent initiatives which he has taken to the public. And we're going to discuss a little bit more. So welcome to Pratidhvani, Ashish.
Thank you very much, Pawan. Thank you very much for your kind invitation.
And I'm very delighted that we have
you here. Absolutely, same here. It's you are doing an amazing thing by bringing so many physicists together on your initiative, and we get to know about their perspectives on their lives, on how they got interested in science and what they are doing now and what their projections are for the future. It's an absolutely wonderful thing that you have started. I'm delighted to be a part of it. Thanks.
Thank you very much. So Ashish, as I generally ask our guests to do, is to introduce themselves through a biographical kind of a discussion. Tell us about, from your childhood, how you got interested in science.
From my childhood.
Yes.
Okay, that is interesting now. You are pushing me to my fifth standard, it seems. So nice. I was in my fifth standard. And this was the first time when I started doing something sciencey. Okay, what I mean is, I saw some toy in a shop where, there was a row of some screws which they had put, and there was another row of some screws, and both of these rows were used as some terminals. And then there was a bulb. Now, if you ask in the first row, if you put some connection in the first row, where there is some question written like what interesting happened in 1947, and then in the second row there is another connection which says independence of India. You put it there and then the bulb glows.
Nice.
Okay, so this was this, and I thought, okay, let me make it myself at home, because I noticed its price and I noticed it was too expensive maybe. So then I started making it myself. In fact, there was a science fair coming up in our school. And my father immediately got interested in helping me with this. In fact, he made a wooden board. He went to the market, made some wooden board from a carpenter, and we drilled holes and we put some screws in there. We put wire connections there. And what we did was we made actually 3 rows of these screws, and we wrote in one row, okay, vitamins, what happens if there is deficiency, how to cure it. Okay. And then there were these 3 rows, and then we used to there were these 2 knobs, and there was a bulb battery, and then the bulb used to glow when the vitamin A, for example, went to blindness, deficiency, how to improve it. Okay, eat carrots, for example. Eat vitamin A, and so on. Nice. So this is where it started. However, there was an interesting thing which followed was the following. There were 2 terminals now, and I thought, let's make the bulb grow a bit brighter. And I pushed these terminals in the mains in the wall.
Nice.
And first I got an electric shock because there were some naked wires. The bulb blew off. It was bright for a fraction of a second. And then my father heard this noise.
Nice.
Because I also shouted, I got a shock. And my father arrived, and I got some scolding from him. And the lesson which he gave me was, first, when you are trying to do something with science or with something with some wires or whatever, first try to understand its limitations.
Good.
And he taught me that, look, this bulb is only meant for using with a battery and not with the mains. And then he started teaching me about the voltages and currents and so on. And I immediately got interested in all of these. And then whenever there was any science fair in the schools and so on, I always participated, and my father was always there to help me with building lots and lots of different kinds of setup. I won a lot of prizes. It was very encouraging. I went to the state level. First, there was some zone in which there were like 4 districts, and then there was state level. I also went to the state level and won there, and so on. So we had a lot of fun as a child, and this is where I got all the interest in.
Wonderful, wonderful. It looks like there has been a kind of a culture at home, where you are encouraged to, pursue your curiosity.
Correct.
And that is an important element. And as you mentioned, your father probably was not only your mentor in your earlier stage, but also that openness in the family to be curious. Although I'm not telling that many people don't do it, but it is not natural sometimes. And how did it come about, like through your parents?
You're right. It might not be natural. So it's interesting. Like my mother actually is retired as a school teacher. She was a Hindi teacher, and in her Hindi language books, there used to be always some biographies of some scientists like Marie Curie, Albert Einstein, Edison. So my mother used to tell me all of this with lots of enthusiasm. And on the other hand, my father was very good with his hands, like with technical stuff. He's very good, so I have never really seen in throughout my life any plumber in my house, any electrician in my house, any mechanic in my house. All I have seen is like bunch of tools lying around in his tools boxes, and all kinds of screws and screwdrivers and drill machines and wood cutters and all kinds of cutters, metal cutters, and so on. And I used to get very excited with all of this. And this is where, you see, even when, my father, when he has to get his scooter serviced or my mother's this two-wheeler service, they will do it himself. He would do it himself.
That's actually unusual, Ashish. It's not a normal thing in India, because people who do work with hands, and I should remind our listeners that people who do work with hands also use their minds. Because there is a notion sometimes that anybody who works with hands does not think, which is actually a very wrong notion.
This is wrong.
And if somebody wants to do that, it actually is a very important culture to cultivate. So I'm very glad that you had such an upbringing. And how did that influence you as a person who is now inclined towards science?
So then, when I was in my little higher classes like 10th, 11th, 12th, I got interested a lot in magnets and optics. So in my 7th or 8th standard, actually, I built my first telescope, astronomical telescope, where 2 convex lenses are used and so on. I calculated some apertures, what I need, powers, and so on. And then this we used to get extremely long, because you add the focal length of 2 lenses and it becomes very long if you want to get large magnification. And then due to that, aberrations are high and you need large apertures, then sizes have to be large. And if you want to look at the moon through that telescope, it's not very convenient because there will be aberrations, and only the center of the lens would give you some nice thing and so on. And then I was not very happy with that, and I tried to check like what I can do to improve on this. And then my father went to an optics shop. He was always there, he was like, okay, now you are on a project of a telescope, let me find it out. He went to the optics shop where I used to get my glasses done. And there he tried some combination of lenses, concave lenses, convex lenses, and so on. And then the optics guy, he himself knew a bit. And he told him that, look, if you use a concave plus a convex lens, first of all, it will give you the image which is not inverted, which is like the way it should be. And also then it shortens the length of telescope because it's subtraction of focal lengths now, f1 minus f2. However, the magnification stays the same. And that improved the quality of this telescope a lot, and I was mind blown. Because I had only read about astronomical telescope in my 7th standard, not this Galilean one, and this was amazing. So this is how I learned about this. And then I tried to make some microscope, which I did not really succeed because it needs a bit more of effort and tubes and so on, which I did not succeed. However, my interest went into magnets then. Because my father used to bring these insulated copper wires. When there was some fan which went wrong, he would open that up, and then there would be a coil which would come out. If there are some speakers which went bad, he would open them up. Some coil would come out, some magnets would come out, and so on. And then I was always wondering what to do with these, because there can be many interesting things which can be done. One can make generators, for example, and use these coils to do lots of things. You can create electromagnets and do lots of things. You can make motors and so on. And from this interest, now he was like, okay, let's make something out of this. Now, it was his idea. He made an electromagnetic crane. Now, what he did was he built again a box, with some wheels which he put under it, which he got from some old refrigerator. There were some wheels which came out from the trolley of an old refrigerator. He put under the box. Now, this is the base of this crane. And then he put some batteries in. He makes some shaft there, and he puts a pulley on which he, wraps a thread, and then he hangs an electromagnet from this pulley, and he puts a motor. And then, it was a bi-directional motor. So you have now 2 switches. With one switch, the motor turns counterclockwise. With the other switch, it turns clockwise. So you can put this electromagnet up or down with this. And then there were another lever, and this lever was used to turn it. Okay, let me see. So turn the magnet on and off. So you have to turn the magnet on. If you have to pick some magnetic stuff, like some piece of iron or a chunk of car or whatever, you take this crane there, put the pulley down, and then turn the lever on, which turns the magnet on, and then lift it up, and then put your crane in another direction, put it down, turn the magnet off, and put it down. I was super impressed. I mean, I also helped him in all of this. I was a small kid. I was in 10th standard. I helped him in all of this. And then my school teachers and, my classmates, they used to be super impressed. They were like, this home has something unusual going on all the
time. Absolutely. It is unusual. It is unusual because it's not a normal thing, especially in so-called middle-class families, because the emphasis of education seems not to be thinking with hands, but with something you become like a bookish person. Nothing wrong in that, but there is no kind of, combination of experimental approach to looking at and learning things.
Yeah, exactly. And not only that, then he learned from somewhere that one can use potatoes or lemons to create a battery. And then he brought a plate of zinc from somewhere, a plate of copper from somewhere. I don't know how he used to manage all of this. He had resources lying around somewhere in his friends or in the market or wherever. And then he put some plates of zinc and copper in these lemons, puts them in, I don't know, series or parallel. I don't remember what he did that. And he was able to turn an LED on with this. And then he brought a voltmeter. Actually, there was this voltmeter which he brought from somewhere. This was the first voltmeter. It was 10+1 when I was in. And he used to show me, look, this is the voltage. You have achieved 2 volts with these 6 cells of lemons.
Wow, okay.
And then you can even draw some current from it and turn an LED on. This was quite interesting, and this is how it kept me motivated for science. And then I started to already think that, I have to become a scientist. That's the time.
What a wonderful kind of initiation. That's fascinating. So once you get into this mode of, this kind of experimental approach to understanding nature or even everyday life, that becomes also very fascinating, which also means that you would also be learning things in school. And education at home and education at school can sometimes be out of phase. So how did you try to kind of bring them together?
No, this is very important. Actually, I should also mention that actually I found some wonderful teachers in my school as well. So in my 8th and 9th standard, I actually was accompanied by some amazing people who used to teach me science and mathematics. I would mention some name. One name is Mr. Pavan Gill. Wonderful science teacher. His body language and his way of explaining things and connecting with nature and connecting with the practical life was super. And I learned a lot. Another person was Mr. Dinkar Prashar. So he also was a similar kind, very motivated and motivating in teaching science. And then in my 10+1 and 10+2, there was Mr. Satish Thatwalia, and he was an amazing guy, very, very hard-working physics teacher, very, very hard-working physics teacher. So this is where I got the motivation of working hard and tried to go deeper into the concepts of physics, because physics is something which needs a lot of thinking. And this is what I learned from these guys, that one has to sit and think. If you are, in India, there is some problem, unfortunately, that when we are preparing for this very competitive exams, very challenging competitive exams, because of whatever reason, we are made to work hard in, keeping on writing things and keeping on practicing, solving problems and things like that. And that was always there, because one has to get through this system. Somehow, if you have to go to a good place, you have to go through this system, you have to clear these exams. But on the other hand, what I learned was that one has to think really hard when you are doing physics. One has to think hard. And then writing a lot over and over in solving problems or derivations and so on doesn't help that much.
Absolutely.
But thinking matters a lot. Discussing matters a lot. Yes, that's another thing. I found some friends, company of friends who were interested in physics, and I discussed a lot.
And that's something which is very good. I should mention that, because Ashish is my colleague. In fact, some of the conversations which we have, even over a cup of coffee or tea, is generally very important and so kind of interesting. It is so informal, and yet a lot of times it is educated. And I agree with you. In fact, part of the initiative in Pratidhvani is actually to somehow bring in that spirit together. So Ashish, now going forward, now that you actually have this wonderful kind of ecosystem at home, you are now also getting into higher education. Right? Now you finish your school probably in which place?
High school. So this was actually my hometown called Talwara. It's actually at the bank of Beas River. There is a dam.
Nice.
And this was another thing. So there is a dam, and I used to visit this dam and used to visit this huge turbines and this megawatts of power getting generated there. And my father used to show me these turbines and generators and so on.
So you can also describe this, which state, which district. That will be good for our
listeners. I should do that. So I got carried away with these images of this dam in mind. So so I am actually Punjabi by birth, and the district in Punjab called Hoshiarpur, where this small town called Tarwara is located on the banks of Beas River, on which there is this dam called Pong Dam. In fact, my hometown was actually created to build this dam around 1960s. So, all kinds of engineers and workers and all kinds of people who were involved in building this dam, they used to live in this hometown. So this is where I grew up until my high school. 10+2.
Nice. Nice. Now that you are finishing your high school, so did you have to move out of that place?
Yes. So after that, I got into Punjab University, which is in Chandigarh. It's physics department, because I was clear, I don't want to do anything else than physics for some reason. I appeared for only this exam. And I did not appear for engineering exams. I appeared for IIT though, and completely half-heartedly. I was like, okay, I don't want an IIT, because in those days I did not know that in IITs also one can do BS, MS and so on. Probably in IIT Kanpur it used to happen. This I did not know. No idea. Everyone is talking of engineering in those days. So all I knew was that in Punjab there is this place called Chandigarh, where there is a nice university called Punjab University, and there is a nice physics department. And if I'm able to get into that, that's very nice. So I appeared for that exam, cleared it, and got into this department, in the physics department.
Wonderful.
Yeah, so after that, I just did my bachelor there
Mm.
and found some very nice teachers, found interesting laboratories, not at the level of research, but for
Undergraduate
it was
education.
quite nice, and teachers were quite nice as well, some of them, 3 or 4 of them.
In fact, Punjab University has a good legacy of physics,
Yes,
right? In that sense, there have been many people who have emerged out of that particular place.
That is true. Actually, Punjab University is known also for its first cyclotron in India.
Exactly. Yeah.
Which was actually brought from, which was a used cyclotron, I think, which was brought from the US somewhere.
Yes.
And it's still running, still functioning, and there are still experiments going on, although the technology which is used for running the cyclotron has become old.
Yeah.
There are some tubes which are used to run this, and those tubes are not available anymore, and there is only one spare with them, and after a few years they do not know what to do, because this will go off and then things are bad. But on the other hand, the legacy, as we are talking about, there are many physicists which appeared from Punjab University, and I think Shanti Swarup Bhatnagar, who created CSIR, he was associated with Punjab University. I'll have to check actually. And I mean, the high energy physics group there is very, very active. Yes. So we have a good exposure to high energy physics and also low energy physics on cyclotron level. So these are some of the highlights.
Very interesting. So now, during the BSc days, how was your kind of education? You were trying to already think about what areas you are getting interested?
Oh yes, now things become serious. Because once you are in bachelor and once you are doing an honors in physics, you come across books of Richard Feynman immediately, and then becomes suddenly very interesting and serious. Because these books kept me alive during my BSc. I kept reading their chapters of Richard Feynman lectures on physics. I noticed them now in your cupboard in your office as well, volume 1. And now at this time one has to start thinking, okay, we like physics, but what kind of physics we want to do as profession as well. Because at that level also, all we are doing is going into the basics of everything, all pillars of physics, and there are many. And then mostly we have an exposure to theoretical physics because of the culture of universities of India. Unfortunately, the experimental physics needs a lot of money. And that kind of money is not really available. So one gets to know lots and lots of biographies of serious physicists like Paul Dirac, like Albert Einstein, like Richard Feynman, and all of them mostly are theoreticians.
Absolutely. So, I'm glad you were mentioning this because I also had very similar education because I did my bachelor's and master's in State University, in Bangalore University, especially master's program, had very, very strong component of mathematical physics. And they were all very competent people who were teaching. Experimental one was not that great. Only few of them were very good. But this, as you properly mentioned, and it's a very important point, that actually has become an important aspect why a lot of good theoreticians have also emerged out of India. That is a good reason, but not great for experimental training.
That's true. That's true. And this is sort of unfortunate because the exposure to science has a very important component from experimental physics.
Absolutely right.
Extremely important. I mean, unless a theory is tested by experiments, you never know if the theory is right or wrong or what's going on.
Absolutely.
Right? So this training is also very important to go through before deciding a career. But I was sort of already decided because of my exposure since my childhood. So I knew I was interested in experimental physics, but again, I was sort of drawn into theoretical physics because of this exposure. And, once I finished my bachelor, I was almost certain that I want to be a theoretical astrophysicist.
Okay. That's nice.
Okay. So what happened was I applied for the summer school to Ayuka in Pune. And this was my first exposure to Pune, and I came to Pune for 2 months.
Did come? Okay,
I came to Pune for 2 months.
Nice.
And I did a summer project on analyzing the cosmic microwave background radiation data from WMAP observatory. And this was 2006. And the person who was my guide was Professor Tarun Shauryadeep.
Tarun, yes.
Okay. Yeah, so Tarun was the one also then I encountered later on after 17 years.
Wow.
No, 16
years. I
years.
should mention to our listeners, Tarun was our erstwhile chair at Department of Physics at IISA Pune and our dear colleague who is now the director of Raman Research Institute.
Correct. So amazing experience at IUCA. Amazing experience. Like for the first time, I was among those people who were passionate and who I wanted to be around with. Like who thought like me, who wanted like me, who wanted to do serious science and so on. But again, I was not really sure because after this summer school, I was like, okay, so this is what theoretical astrophysicists do, because there was this very strong exposure in this school to lots and lots of theoretical astrophysicists who gave us lots of lectures and so on. And then I learned that maybe this is not for me. I mean, of course, this is a great thing, theoretical astrophysics, because, you know, I always wanted to do things with my hand. And I was like, okay, I have to build magnets, I have to build optical setups and things like that. And this is probably not what this is. I mean, this looks exciting, but as a profession, probably it's not for me. Because I am sitting on the desk all the time, reading papers and analyzing data and things like that, or trying to write some expressions and things like that, which did not really inspire me too much. And then I joined TIFR for my PhD. For
your PhD. This is
master and PhD.
Master, because you were you joined there as an integrated
PhD.
So for listeners, integrated PhD program generally has a kind of a master's and a PhD kind of integrated with each other.
Yes.
This is generally done after the bachelor's program.
Yes. So now I am in TIFR. This is 2006, and a very strong coursework starts. And a huge exposure to experimental sciences begins.
Nice.
But it was actually a bit too much now. Because first semester, and we are supposed to do 10 experiments. And those 10 experiments are happening in different laboratories. And those are all research grade experiments. We have to, for example, lower the temperature of a superconductor and check where the transition happens and how it happens and measure things and so on. For example, and then, you know, this was a semester of 4 months in which we are supposed to do this plus 5 other courses, and this was a bit too much. And I sort of started to feel a bit demotivated now. And that was not nice, because first of all, I got sick in Bombay's weather. This sickness went on for 2 months.
Oh wow! As soon as you joined.
As soon as I joined, because I had a strong stomach infection and very strong fever, and then this strong coursework going on, and I'm not able to perform really too well. Like, I was a gold medalist from Punjab University, but now after first semester in TIFR, I was in the end. And this was quite demotivating, and I'm like, I am probably not for physics. This was after first semester. Okay, second semester, a bit better. I still feel a bit demotivated. I'm like, no, people around me are way too smart. And I'm probably not too good for physics. This is what I started to feel. That was a low time in my undergrad or whatever, this graduate school life. And I was almost going to quit physics. Wow. I had decided that I will join some master in technology program, because again, the thing that went in my mind was always these hands-on things, magnets and optics and whatever. And I was like, I will do some master in technology in instrumentation from Indian Institute of Science. This was my plan back then. And I appeared for GATE exam or whatever and so on. Yeah. Cleared that, because in those days, you know, we had just done bachelor and the books were freshly there in mind, and we had worked hard during bachelor, and then all exams we used to clear easily. Now if I have to give all the exams, I'm sure I won't be able to qualify.
Exactly.
In any case. So, but then in my third semester, I happened to do a project again in astronomy, and there was a telescope which was being built in TIFR. This was AstroSat observatory.
Which is actually also some kind of interesting developments are happening now. Yeah, please correct.
So exactly. At the present moment also development. So AstroSat was supposed to be an X-ray observatory which was supposed to go around the Earth and look at the X-ray sources in X-ray wavelength. So it has to see the X-rays coming out from various sources from the universe and analyze data and find what's happening, what's going on through this X-ray window. And there was lots of optics in there. So I joined this laboratory just for 2 months for a short project, and I learned how to deposit thin films of gold to build some gold mirrors on some aluminium sheets, thin sheets, and so on. And this was an interesting experience. This was a bit refreshing, but still I didn't see where I am doing science in there still, because I wanted to bring science and instrumentation together. And then I started going around other labs. Now, the thing is the following. These integrated PhD programs, I like them a lot because they give you a lot of opportunities to go around, to move around and to explore your interests. You can go to various laboratories, you can go to various theoretical physicists and do some short projects, and you can explore your interests. And this was very good for me. Because I was, as I told, I was getting demotivated, but suddenly some things started falling back. My interest started falling back. And I joined, I went to some person called Professor B.M. Arora, who was almost going to retire. He had 1 year to go. And I checked what he's doing. What he was doing was, he had this big superconducting magnet, which was lying in a cryostat, which had this liquid called liquid helium, liquefied gas, and this brings down the temperature to 4 Kelvin, like 269 degrees below 0 degrees centigrade. This is already exciting to me. And then I see, there is a superconductor now in which you pass current once. The current does not stop. You just turn the power supply off. It keeps on running there, and the magnet keeps on, getting charged. It's producing like huge magnetic field, like 8 Tesla. Now this was huge for me. The fridge magnet is like 0.1 Tesla, 0.01 Tesla rather. Like, so 8 Tesla is like 800 times more than that. So this is huge. I mean, I was surprised that this can pull objects from very far, and one has to keep check on what you have in your pocket. If something starts flying around, then you can hurt yourself and so on. So then I was impressed. Okay, my thoughts went back to the childhood. Magnet. So this is a huge magnet now. And the other thing which I saw was there was lots of optics lying around on this table, where there are shining light from various sources, lamps, lasers, and so on. And in the optical fibers, the optical fibers now take this light inside this cryostat in the magnet, and then there are these samples in the magnet. Some serious physics happening there. Now, what kind of physics? Like, physics of 2 dimensions now. Now, this brings in some theoretical physicists also. Now, theoretical physicists always used to talk about, like, multidimensional multidimensional physics and so on. I'm like, okay, multidimensional, but let's reduce the dimension. Let's go one lower dimension. Now this is 2-dimensional physics, and the physics becomes very interesting there, because what happens is, like, you produce some hydrogen atom-like things in these materials called semiconductor quantum wells. Now these semiconductor quantum wells, meaning these are very thin crystals of certain materials, such that if you put some electron or a hole in that crystal, it stays confined to move only in 2 dimensions, in X and Y plane, for example, and the Z direction cannot come out of the crystal. There is an energy barrier there. It cannot come out. So this is a 2-dimensional aspect to this. The electron and hole are only able to move in 2 dimensions. Now the thing is, these electrons and holes, they can come together for a very brief time, and they can create a hydrogen atom-like species called an exciton. Now essentially it is like a hydrogen atom which you have produced in a crystal, but now it's 2-dimensional thing.
Very nice.
The thing is the following. All the kind of experiments that we do with these excitons, these 2-dimensional species, for example, 2-dimensional excitons. Of course, excitons are also 3-dimensional, but here we are only talking about 2-dimensional. So all kinds of things that you achieve by making some measurements and trying to get the physics out of these excitons, it exactly resembles the physics of hydrogen atoms, the quantum mechanics of hydrogen atoms in 2 dimensions. Now, this looked very interesting to me because firstly, it brings so many things together. Atomic physics. In atomic physics, you can do experiments on hydrogen atoms, sure, but you cannot produce 2-dimensional hydrogen atoms. Of course, we can write Hamiltonians and quantum mechanics of 2-dimensional species, but we cannot like check them experimentally in atomic physics. Okay, so this was the system which brought me to this nice area of 2-dimensional hydrogen atoms. Wonderful. And then you have optics, which was my first love. And then you have magnets, which was also my first love. Okay, Zero's love. Both of them were Zero's love. Magnets Wonderful. And optics.
So I want to just pause at this particular point, and I wanted to kind of ask you a few specific aspects. You mentioned about a point in your graduate studies where you are about to quit.
Yes.
This is actually a problem a lot of people face, especially when they move from a place where they would be very comfortable to a place where suddenly it becomes extremely not competitive, but which actually takes them to a slightly more higher level, puts them right into an arena where they get exposed to something very new, something very, very, rigorous and other things. You did not quit.
Yes.
Although you did mention the process, what was happening in your mind, Ashish? What was that which actually, somehow brought you up to the speed and made you think that you would be able to do it? Because this is actually a make or break junction, right?
Yeah, exactly. So I mean, if I understand, you are asking like what made me stay back.
Yes. What really? What was your thought process then? How did you make the decision?
So the decision was simple. The decision was Professor B.M. Arora and his lab.
Beautiful. Very nice.
Because, I was suddenly at home. In fact, better than home.
Nice.
Because now I have a magnet and a superconducting magnet which produces huge magnetic field. I have these lenses and these mirrors and all kinds of optics lying around. And this gave me kick. And then I have to play with this liquid helium and liquid nitrogen and all these things which are very challenging to handle. But once you learn all of this, how to handle this is a lot of fun. This is a lot of fun. And then I'm like, okay, this is exactly the place which I wanted to be. Because now here I can make my own things with my hands. For example, I can make all kinds of setups with optics, and I can use all kinds of ideas to work on and so on. And then Professor B.M. Arora, he is such a person that you get addicted to him.
Yes.
You start talking to him, you start talking science to him, you get addicted. You are like, no, this is the life which I wanted. This is the person and these are the people around, and his team also there. These are the people I want to be in. And then there was no question at all to have second thoughts of quitting.
Fantastic. See, this is something very, very important. That is the reason why human element is so critical in doing science. Because we think, okay, objectively, somebody who has done very well, you are a gold medalist in your bachelor's, and coming also from a good university where you had a good foundation, but suddenly you are put in a place which is kind of literally foreign to you, in the sense you're trying to adapt, your health is not doing fine, and suddenly you find a kind of peace and semblance in particular place.
Correct.
Which you can take it forward and do things.
Correct. And the peace was in having these challenges at hand now, which I loved. This was the peace. Because people who want to do science seriously, they always want challenges.
Yes.
They always want some problem at hand which they want to do.
Yes. It's kind of committing your life.
Exactly. Yes. And I was not able to find that problem for many years.
Nice.
And finally I found, and then there was no
time turning back. Beautiful. The second point I want to kind of ask you is that very strong culture of experimental science in TFR.
Yes.
I have visited there, know a lot of good people.
Yes.
Hopefully I'll also have many of them on this podcast. But one of the very impressive aspect of TFR Mumbai and also in any other
Yes.
institutions related to TFR is that culture of strong physics
Yes.
and a very strong culture of experimental physics.
Correct.
Would you want to emphasize? I'm looking at it
Yes.
from a person who has done his education from there. You can always talk to a
Yes.
professor. They would also have a different
Yes.
viewpoint.
Yes. Yes.
But I'm very interested in knowing the education aspect of it.
Yeah. So this is a very important point which you mentioned. So let me go back to that place when I did then my master thesis with Professor B.M. Arora. And the culture will come out automatically from this small story, which I am going to tell. So there is this laboratory where we are working now, where we are trying to measure something called photocurrent, meaning we are shining some light and we are measuring some current. And we are trying to understand these hydrogen atom-like species because they are made of electrons and holes, and when they break, there is current. So they are alive only for some time, but then they break and then there is current. Now, this experiment was very challenging, and challenging experiments like these are not really possible at many places in India. Okay, what I mean is the following. For example, there is a home-built magnet system, superconducting magnet system, which was, some cryostat which was very old, in which some superconducting magnet was bought and it was put in there by a person called Professor Vishwajit Karmakar, who is now in Saha Institute of Nuclear Physics. An excellent experimentalist. I had just spent 2 days with him when he trained me on his system, and it was absolutely wonderful time. Now, what I learned was during those days, we were building some setup, and this setup was completely to be built in-house. And this was a precision machining which needed. So the thing was the following. The idea was we have to take polarized light inside the cryostat through an optical fiber. Now, when you take polarized light through optical fiber, polarization is gone. So what to do? So what to do is we put this polarizer and this quarter wave plate, because we have to produce circularly polarized light there, right in the cryostat at 4 Kelvin, just above the sample. So we make our own sample holder with places to put small, lenses and this polarizer and quarter wave plate and so on. Now this needed precision machining. I thought, maybe there would be some factory where they would do this. But then I go with Vishwajit to this workshop of TIFR. This is now this huge workshop of TIFR where there are all kinds of machine. I mean, you think about something to machine and it's there. You think about something, okay, for example, I have to make some crucial parts for a satellite. Okay. And these parts would need machining from very thin metallic pieces, and they have to be combined, and then their specific shape has to be given, and so on. And all it has to be done all in a very precise way, and it has to be done using computers and so on. Everything is there. Nice. In that. I was very impressed looking at all this facility where we built certain part of this setup. But this was not all, because these machines, they turn off at 4 o'clock in the evening. Okay. And then everyone goes home. Now we are not allowed to enter this workshop, but Vishwajit and I had only 2 days. So we had to use nights. Okay. So Vishwajit was very good. He is very good with hands. He is very good with machining himself. All he needs is machines himself, the access to machines. Now there is a small workshop as well, which is personal to the condensed matter physics department. We go there and he starts to turn all these machines on. He finds all the equipment and he starts to machine everything himself. And overnight, like maybe we spend 8 or 9 hours. Wow. And we have done. We are done by the morning. He has braced everything together. Wherever some welding is needed, he has done. And I'm just looking at it with an astonishment on what is happening. Am I in some magic show or what?
Magic show. That's a good one.
This was a magic show for me. And then we have this very finely machined equipment at hand, which we have just built. I could not imagine doing all of this. I mean, but it was there. All of this was there. And then we built this setup. By the evening, we saw the first signals, which we wanted to see. Everything works. We reverse the direction of magnetic field. The signals reversed, and everything is working fine. The polarization is fine. Current is coming, and Vishwajit says, "Okay, Arora ji, you are good to go." And I am also good to go. I have to go back to Italy. So he had come from Italy. He was doing a postdoc.
Okay.
And then, this is how I got inspired with all these facilities.
Fantastic.
And there's this huge liquid helium plant in TIFR where you liquefy helium, and this helium is put in containers, liquid helium, and then is supplied to labs. And now helium is an expensive gas, so it evaporates. And then in every lab, there are these tubes which go back to liquid helium plant where they collect this helium in these huge balloons, and then they are compressed back into these cylinders, these very high pressurized cylinders where the pressure is huge. I mean, I don't know, 200 bar or something, or 250 bar, something like that. And then that is used to liquefy it again. So I was very impressed with all these facilities. So TIFR actually was a very nourishing experience for learning.
Beautiful.
But this was only until master, I have told.
Yes.
This was something where the interest was building up. But more serious stuff started happening in my PhD.
Yes.
Maybe, I don't know if you want to pause me here.
Okay. Please go ahead.
Then my master thesis was finished, and it finished with in fact a paper. And because we wrote a paper saying that yes, we can build such setups ourselves by putting all these optics at 4 Kelvin, and it works.
Wonderful.
All you have to do is to paste these optics with a very small dot of a glue, and don't put glue everywhere because the optic will shrink and will break. But the small dot of glue, it helps to stick the optics there, but at the same time it also leaves a room to compress and expand with and there is no strain also, so with temperatures. Anyway, so after that Professor Arora retired. Soon, and his lab was dismantled. And this was a personal it felt like a personal loss to me.
I understand.
Because I helped building some setups there, and it was we got a paper out of it as well. And this was on instrumentation and exactly the things which I had thought of since childhood, like magnets and optics. But then I found that Professor Arora's ex-PhD student now, who was also associate professor there, I think, Professor Sandeep Ghosh.
Yes.
And he is available for guiding me for a PhD.
Nice.
So this was already decided when I was doing my master. And then when I talked to Sandeep, he, like, what we are going to do for a PhD, he said that we will buy a superconducting magnet, we will buy a electromagnet, we have to build setups. I'm like, okay, again home.
That's
back to home. So I immediately joined this lab. And again, low temperature stuff. We have to build these setups, which are now supposed to be very high precision magneto-optics called curve rotation spectroscopy and so on. And doing curve rotation spectroscopy is not very easy because you have to, achieve wavelength dependence by playing some tricks with the setup. And these tricks we solved, and we also published all of these tricks after we solved them. For example, the first thing that we solved was how to transport light, polarized light, in various corners of lab without destroying the polarization. And Sandeep had this wonderful idea that if you just make a 2-mirror arrangement, where if you make one reflection, suppose upwards, another reflection then maybe in the right direction, then we called it as a twisted periscope arrangement. And this will, if the 2 mirrors are alike, the polarization stays the same.
Fantastic.
And we proved it using some experiments called ellipsometry.
Yes.
And then, first puzzle was solved on how to take light from production to detection or to the sample and so on. The second problem was how to achieve Faraday geometry where magnetic field is perpendicular to the sample and light is also perpendicular to the sample, but we have to use a broadband lamp and so on. Okay, I'm not going to go into details, but there were challenges which we wholeheartedly accepted to solve, and we solved.
Wonderful.
And it was a very nice experience. And then there was a superconducting magnet which arrived into lab, and we set that up. We did lots of interesting physics of hydrogen atoms.
This
hydrogen
atom equivalence in solids.
In solids, called excitons.
Excitons,
And we did all this physics, various aspects of these, like how they behave in under various strain environment. When you put strain to hydrogen atom, you shift the lattice constant of the solid, what happens, and so on. And when you put them in high magnetic fields, what happens with this sensitive spectroscopy techniques such as magneto-optical curve effects, all these things. And this was very nourishing. This was completely thoroughly rewarding, because in all of these 5 years which I spent doing all these experiments, I was meeting all kinds of people from technical and physics way, because the technical staff of TIFR, it's huge and it's extremely talented.
Yes.
And you go to this workshop and you make friends with them, you go for tea with them, and you keep on discussing these ideas on how to build various things. And it's amazing. I mean, and the low temperature facility people, they used to come to the lab just at I just would say, call them, okay, I have this problem in the lab where helium has started to leak from a tube. They would immediately bring their brazing kits, braze that, fix the leak and build things and so on. This was all very rewarding. This was a culture which was sort of unparalleled. I did not see this even abroad.
Fantastic.
This culture.
Fantastic.
Yeah.
Beautifully explained. So now I'm going to kind of expand on your future further experience after PhD. So you graduate in which year?
2013.
2013. And then you move to Europe.
Yes.
Which turned out to be one of the very interesting periods of your experimental career.
Correct.
Tell us the transition and the trajectory.
Yes. So now, my PhD supervisor, he trained me in a way that I became extremely careful in handling optics and setups and in thinking very deeply into the data and analysis. And he was also he is a very good statistician also. You can notice many of his papers are also in pure theory. He does this something called K.P model calculations, for example, which is a perturbation theory calculation to find the effect of strain on various things such as these excitons and so on. And I learned all of this theory also. Now, after this training of being very thorough and careful, I was like, okay, what next? Is the training going to be different or the same when I'm going to be in postdoc? Because when you are going to think of a postdoc, you are going to a new country where probably the language is not yours. People don't speak English even there. Culture could be completely different. It could be quite, challenging to adjust. And then the main challenge during the postdoc is that, look, this postdoc position is for 2 years. In these 2 years, you have to prove that you can embed yourself in that culture and you can produce some nice research and papers and things like that. Now, this can get extremely challenging because you are going to an established lab where people are already working and you have to start with your own project somehow. Start getting into that lab and using their setups or build your own setups. And so I did not know how it will be done. Anyway, so I had applied to many positions. No one in America. I only applied to Europe. The reason...
Why? Is there a reason?
Yeah, there was a reason actually. Because I talked to so many people and I found one thing which was common. And the thing that was common was that, I don't know if it's true or not, pardon me, because I have never worked in America.
Yeah, well, absolutely fine.
So the thing that I heard from everyone was that in America, the culture is such that you are not really having a work-life balance. You are working probably day and night in a lab, also probably on the weekends. And that could be challenging at times. Of course, I was trained in this way in TIFR, but now I started to think about some work-life balance. Because I wanted some discipline in life. In TIFR, we were not really disciplined. We were like, sometimes I would come at 2 in the afternoon and leave at 6 in the morning. And this was not sometimes, this was most of the times. My supervisor would come at 11 in the morning, maybe or 10:30, and he would leave at 3 in the morning. This was his routine. Like, he would sleep maybe 6 or 7 hours and then he would be there until 3 in the morning. I wanted to somehow deviate from this. And I learned that in Europe, the culture is different. In Europe, you come at work at 9 and leave at 5:30 or 6. But at work, you only do work. No websites, no phones, nothing. You stay very sincere, you stay very disciplined, and you also enjoy life.
Absolutely.
And this is something which I missed in India. I enjoyed life, sure, but in a different way.
But it's not a sustainable way of living.
Correct. It's not a sustainable way because, at some point you have to start thinking about your health as well. You have to start thinking about your mental health and all of these things. Like if you are awake whole night, all kinds of hormones are released at night, which are supposed to be released when you are sleeping and not when you are awake.
Absolutely.
So it can affect your mental health. And I had started feeling all of this as well by the end of PhD, that there could be some changes which are coming. In any case, so I got an offer from this laboratory called National High Magnetic Field Laboratory in France. In Grenoble. And this was unique because as soon as I visited them for giving an interview, I learned that they have these huge magnets, which are some of their kinds in the world. Like such facilities are probably there at 3 or 4 places in the world, where you produce a magnetic field of like 35 or 40 Tesla, 38 Tesla. And this is not easy to produce because you use some generators, a powerhouse really, for powering this magnet, which is like 24 megawatt.
Wow.
Now this 24 megawatt can be used to power, for example, 5 Rajdhani express trains all together. So this is just for one magnet. And now this magnet heats up, so you have to cool it down. So there's huge water pumps and you pass like 300 liters of water every second. This water enters at like 16 degrees centigrade and leaves at 95. So you get water from one river. There are 2 rivers between which there is this magnet facility. You take water from one river, pass it through magnet and push it to the other river. So
fantastic.
Something like this was happening. And now this was crazy. This was like, okay, this is dream. Some huge facilities where you can work now. And this is not only that. Of course, this is an instrumental aspect, but look at that. You have scientists coming from all around the world. To do their experiments there. Because to get the time of this facility, it's very challenging. Because you write some proposals and then these proposals are evaluated and only some proposals are awarded, others are not. And by awarded, what I mean is like one magnet time is of the order of 40 lakh rupees. So you stay 7 days there to do your experiment. For 40 hours, you have an access to magnet and 1 hour costs 1 lakh rupees to just run this magnet. So this was crazy. I was like, okay, this is the place where I can grow a lot by meeting lots and lots of scientists from all across the world. Some of the best in their area of research. Of course, I had access to this facility also, but this was also through proposals. Because this was a facility which belonged to European Magnetic Field Laboratories, which are 4 in total. And you can only get through after this whole commission checks your proposal and awards. It doesn't matter if you are in that lab or not. If your proposal is not sound enough, you are not going to get an access to this facility. There were, of course, superconducting magnets and so on. If your experiment is not there at this big 30 Tesla magnet, you do it 14 Tesla with the superconducting magnet. Anyway, so this was very rewarding. This experience was amazing because my supervisor there, Professor Marek Potemski, an amazing person. This person is like a no-nonsense guy. You go to him with some thing at hand, some problem or some issue at hand. You get an answer in a few words or in few lines, and he will not, speak much on explaining it too much. You have already understood it. So he knows where you are and he knows what you are capable of, and he tells you exactly the thing that you want to know. But on the other hand, there is another aspect. You go to his office to discuss fundamental physics, you take a textbook, and he would discuss with you 3 hours, 4 hours, all kinds of physics in details. These are two completely contrasting things, because one thing is extremely technical and modern research. He would speak only a few words on that. Other things he leaves on you to find it out. On the basics, he would speak to you for many hours, and this was
unusual, actually.
This was amazing. He would bring a pen and paper and he would start writing equations, start drawing diagrams, start explaining to you all history. He would tell you history of magnetism, magneto-optics, and all kinds of people who are involved in the field and so on, because he was the one who had learned, who had lived this, who had lived this field himself. Anyway, so, but after a year of spending this enriching time there, I shifted to as a Alexander von Humboldt Fellow in Germany. So for 2 years, I was an Alexander von Humboldt Fellow in University of Münster in Germany. Münster is a small town very close to Netherlands. So it's in the north Germany. And a very cold town where most of the time there is no sunlight. It's always raining. Münster and monsoon sounded similar to me. And for a few months, maybe 2 months, you get some sun. And it's another challenge now because it's a cold place and rainy place. Anyway, but the physics was superb.
Nice.
Again, I found the facility similar to previous places such as in Grenoble or in TIFR. There is a super precision machining workshop in Münster, and then there is this liquid helium collection plant and so on. So all of this is again there. So I felt very home again there. But the only thing that was not there was this large magnets, like this superconducting magnet. There was a small magnet, 1.4 Tesla. So this is what I had to use. I was used to now these large magnetic fields by now and all my experiments. So I used to go back to Grenoble now and then to do experiments. I kept on writing proposals and kept on winning them and kept going back. 6 or 7 times I went back and did experiments. Wonderful results from there, very nice papers and so on. But on the other hand, I was like, okay, with this small magnet, since I have this at home, I have to build high precision techniques so that I can improve my signal to noise ratio by 50 times. And then whatever I'm doing in 50 Tesla, I can do in 1 Tesla also, right?
Nice.
And this is something which we achieved when it was COVID, because this was a very challenging thing to achieve, extremely challenging. Because, we have these materials which are the thinnest materials of the universe. They are like 100,000 times thinner than your hair thickness. So these are the materials, these are some semiconductors on which we are supposed to learn two-dimensional physics now.
Nice.
We are supposed to learn how these materials can be used for various quantum phenomena, to use them for devices and so on. We have to investigate quantum phenomena in these. Very interesting subject. But the challenge is that the size of these materials, lateral size is very small. 1 to 2 micron or so on. So in these sizes, I had never really worked on high precision techniques earlier, because in TIFR, when I had developed high precision things, that was on very large crystals, like 5 mm by 5 mm, 7 mm by, but this was like 5 micron by 5 micron. This became extremely challenging. The optics became quite complicated, and the magnetic field started doing various things to the optics and the complications, and then the sample would move a bit because magnet is always compressing the body of the magnet, called magnetostriction, or cryostat is always moving the sample a bit, even if it's a bit, like I learned that even if it's 50 nanometers of movement over a period of like 4 minutes or 5 minutes, this is devastating and I'm not able to do my experiment. So these challenges we overcame slowly, and during COVID times it was quite fruitful as well, because I had a fresh look on all of this. I left all other projects and just worked on solving this challenge.
Wonderful.
And then it was done. It was just published last year actually, and I am quite proud of that work.
Fantastic. Fantastic.
So this postdoctoral time in Germany was quite rewarding.
You also became a junior kind of group leader, right? There also that is
So after that, now this is interesting. So Alexander von Humboldt Foundation in Germany, they give some postdoctoral fellowships, and then you are quite independent because first of all you are getting a decent amount of money. On the other hand, the university in which you are working has nothing to do with it. All the administration is lying in Humboldt Foundation, and Humboldt Foundation is extremely anti-bureaucratic.
Oh, fantastic.
There is no bureaucracy, man. I mean, you just call them and say, look, I have some issue with my insurance. And my doctor refused to take this insurance card. They would say, don't worry, we will handle this. And they would call the doctor and they would handle it. And I would not even know, I'll get the letter saying that everything is sorted.
Fantastic.
I mean, and then you say, okay, I have to go abroad and I have, I need flight and so on. You will get your flight ticket and so on next day and things like that. And it's
in fact, this is something I've heard from many people because it is probably one of the organization which will not only have an association with you for those years, but it is a lifetime kind of an interaction.
That is true. So every 3 years, for 3 months, I can go to Germany, funded by Humboldt Foundation.
Wonderful.
So it's a lifetime.
Fantastic.
Thing. So that's very nice. But why I was telling you all of this was that I was spoiled because I got so independent. There is no teaching required, no bureaucracy. Rather, university's bureaucracy is not even close to. I mean, so no bureaucracy, and then I was addicted of being independent because then I learned that once this contract is over of Humboldt Foundation, I will be given a contract by the university where I will have to teach. And the teaching can be a lot sometimes. But I wanted to travel around by doing research in Grenoble or in India or wherever. I was establishing collaborations, and with regular teaching, it becomes difficult during postdoc time. Because in the postdoc time, you have to keep on writing proposals, you have to keep on writing papers, and all of this can become hectic very fast. I thought, okay, teaching anyway, I have to teach at some point. As an assistant professor, or maybe later years of postdoc, I will voluntarily teach. I love to teach, but at that time my priority was different. So at that time, then I started looking for other options, and I applied for German Research Foundation grant, which is called Deutsche Forschungsgemeinschaft. So this grant, again, very challenging, but it gives you again Humboldt-like experience of independence. No teaching, and it's your own grant money, and you also get money for lab. It's significant money for lab, like of the order of 50,000 euros for lab. Also every year.
That's good.
And then you can also take master's students and guide their thesis. You can't guide PhD students because the grant is for only 2 years. So, but you can unofficially, of course, all the time do that. So the addiction continued of this independence. I was a junior group leader now on this grant, and I had master thesis, and my first master thesis was quite successful. We got a PRL out of that, and second master thesis was also quite nice, and so on. It was quite nice, very rewarding, and very independent experience. So this went on for, based on the performance which we gave on this grant, I requested for an extension. We extended it for 2 more years.
Nice.
So that was quite nice. Not 2 really. Due to COVID, it was extended a bit more. So it was extended. And so the total time was 4 years.
Nice.
So 4 years I was on this position when I was also starting to look for positions in India coming back.
Tell us about that point. Now we take a turn back to subcontinent.
Okay. So how much time do we have?
We have some time. Don't worry.
We have some time.
No problem.
Okay, because
No, because briefly, at least give us, because I want to also get into your laboratory current research.
That's very important.
That's the reason we are now making a transition.
So after all these experiences, and I had started applying back for coming back to India. Quite challenging because these were COVID days. And I had sent applications only at 3 places. My only reason for coming back to India was that I want to be first among good people. I want to be among people who also speak my language, and I want to do science outreach. But at the same time, I want to be in a good city.
Hard Venn diagram problem.
Good city as in there should be low levels of, let's say, pollution. There should be decent level of traffic, not much. And it should be an academic city. because I wanted to be surrounded by academicians and all kinds of academics. I mean, there has to be biology, physics, chemistry, industry, whatever, all kind, colleges, and so on. So there were only two cities which fitted this Venn diagram. One is Pune. Other, can you guess, or do you want to guess?
I have a bias.
Yeah,
Bangalore.
You will say Bangalore. Okay. No, Bangalore actually did not happen for me because Bangalore, I found it too congested. Because I had been in Bangalore in 2016. Immediately after that, I had come to Pune also.
Okay.
And that was the days of demonetization when I was in Pune, in ISER Pune.
I was in Goa.
Oh, you were?
Actually, on the day of the demonetization.
Okay. Yeah, so lots of fun went off. Anyway, so, one was Pune, other which fitted to me was Hyderabad.
Nice. Yes.
Okay.
Yeah, I should mention, there are many cities which qualify this.
Yeah.
And,
Could be, but these were the two which fitted for me, for my personal situation. And then I applied to Pune and Hyderabad. I got one offer from IIT Hyderabad. Other offer I got from ISER Pune. And I had also sent an application to Bangalore, which you said, which I wholeheartedly defended. But the defense was just too early there. This was my first application and my first in IISc, my first experience with such an interview. I was not really prepared as well. On the other hand, Hyderabad and Pune, they went quite well, and I decided to come to Pune. Now, things immediately took a different turn once I came here. The COVID had vanished, more or less. I was put in quarantine surely, but
this was which year exactly?
This was 2021, September 21. So after something like 8 years in Europe, I was back. So, I immediately started enjoying interacting with students and the faculty. The faculty, extremely charming, very young mostly. Even if they are old by age, they are very young by heart and by the way they interact.
Okay.
No hierarchy really.
No
I did not feel any hierarchy here. And but still I started to feel some challenges because I'm an experimentalist. And now as an experimentalist, when you come back to India, there are some obvious challenges. The number one challenge is the following, that in India we do not produce high precision equipment, right?
Very correct.
Everything we have to import. Mostly, I would say 95% or 90% we have to import. This is quite unfortunate. The government is trying their best to get over this, but with limited success so far when it comes to high precision equipment. The thing is, on the other hand, the import has become extremely difficult. Because if you have to get something from abroad, one has to go through many different channels of approvals, also approval from ministry, from Delhi and so on, which slows down things drastically. Now, as scientists, when we are competing with the whole world, because my ambition is to stay among the best in the world. That's why we are doing science in ISER Pune. But when we are competing with the world, and if we are facing these challenges that we are ordering some screws and they are coming after 6 months, it's not a nice situation.
You're right.
So that became challenging. The other challenge is, money. Because, to build a high-class lab, which I was used to, like in TIFR or in Grenoble or in Münster, one needs of the order of 4 to 5 crores to begin with, easily. And the rule of the government at the moment is that you will get 25 lakh as a startup money, and after that institute can help. But institute also is tied. Institute is not able to help too much. So one can get 60 or 70 lakhs total of this, which is spread over a year or so. But all our equipment, is quite expensive. For example, if I have to buy a magnet, this will cost easily 60 lakh. So one can just buy a magnet and nothing else. Our experiments need a spectrometer, which can be 70 lakh, superconducting magnet 2 crores. And then other things, optics, optical tables and everything, and cryostat, all of these combined will need 2 crore more. So these become quite challenging to put one experiment together.
Yes.
On the other hand, the most interesting aspect which I found in India is the feeling of community and the feeling of, I don't know, society or whatever. So, as soon as I came here, I started getting in touch with some excellent faculty members who are excellent experimentalists, such as Professor G.V. Pavan Kumar, such as Professor Umakant Ramo, such as Professor T.S. Mahesh. And I'm telling these names because these are the names who actually helped me kickstarting my lab by donating equipment. So first, Professor T.S. Mahesh, he has a room lying around when I have just joined, and this room was used by a postdoctoral researcher who had moved for next things in life, and then he offered me to start things there. Now in this room there is a very nice cryostat, there is a magnet, there is a optical bench. So to begin with, I have something which is already impressive because this is a high-end equipment. What I don't have is a spectrometer, without which I can't do much. What I don't have is now optics, and what I don't have is a cryostat where I can do optics experiments, microscopy experiments.
Yes.
So those challenges now I have to beat. So what I do, I start writing grants after grants after grants. So far, I have submitted, some 17 proposals.
Wow.
So I kept on writing wherever I was trying to look for some money, wherever I checked there is some money available with some agency or some agency with foreign or whatever. And some I got success, like I got core research grant, which was a bit more than 50 lakh in total, and some other grant like Chanakya Fellowship from iHub Foundation, some other money from iHub Foundation of IISER Pune, and some other projects also. Something called STARS project, which is of Ministry of Education, which got approved as well, and I got like 50 lakh from there and so on. So things started to roll. The challenges, which are bureaucratic challenges, soon I got used to. And everything which needed like probably 6 months came down to 4 months because I learned how the system works and so on. And what needed 1.5 years now takes 1 year. So not drastic improvement, but still improvements. And soon I have come to a stage where we are now started to do some excellent experiments.
Nice.
Yeah, with the help from all of the colleagues. For example, from Mr. Pavan, I got lots of optics and lots of optomechanics to kickstart. And not only that, from TIFR, my supervisor, my ex-supervisor in TIFR, Professor Sandeep Ghosh, very kind human. I mean, one of the
fantastic
best people.
Very, very nice. I've had very interesting and nice interactions with him.
Yeah, I mean, it's going to be interesting with him because he's so down to earth and always sincere and smiling and gentle and thorough. I still keep on meeting him and talking to him regularly. It feels like he's still my PhD guide, still a mentor. So he had lots of old equipment which had run out of batteries, meaning that was not really useful for him. But if with some improvements and some fixings, it can be made to work. So he donated me some truck full of equipment, which is very old, but which is very useful. And all this equipment now I'm also clubbing with my experiments, and we have come to a situation. In fact, now I have 4 integrated PhD students and 1 master thesis student, and other project students. Excellent people, because in India, the positive thing is that the students are for free.
Which on a from a viewpoint of a professor compared to US.
Compared to US or Europe, because there you have to keep on writing projects and finding money always to fund students. But here the institute fortunately funds some students. There are the students bring their own fellowships and so on. So this is what I tell my foreign colleagues to make them jealous.
In fact, see, that's probably the biggest strength of Indian research community is the human resource.
Exactly.
In fact, maybe not the infrastructure, maybe not the kind of conventional import and export, etc.
Right.
But people People is our strength.
Right. People are our strength, and the feeling of community
Yeah.
and working together and
Yeah.
standing with others in thick and thin.
Yeah.
This is something which has kept me addicted in IISER Pune. The other aspect, of course, is teaching and outreach. But
yeah, I should mention to our listeners that Ashish is a very, very popular physics teacher here at IISER Pune. And of course, I'm going to come to that small point later. But before that, Ashish, tell us very briefly about what is the kind of experiments you are setting up in currently in your lab.
Okay.
And what are the problems you are interested in?
Yes. So now, the world has moved forward from some two-dimensional semiconductors. And the movement is towards combining these two-dimensional semiconductors with two-dimensional magnets, because magnetism was achieved in 2 dimensions in 2017. It was invented, actually, discovered. So it was discovered in 2017. And after that, there was this push of producing semiconductor and magnetic devices together for future generation of technologies. Now, the challenge is with the present technologies, such as electronic technologies and so on, is that as you are going for miniaturization more and more, you are reaching the quantum limits. And there the devices are not going to work the way they are working at the moment. So the classical computers are not going to work if you are making the transistors even smaller. Secondly, there is always a lot of heat loss. Because, you always are using charge as the property of an electron to produce current. And the promotion of charge leads to Joule heating. And lots of energy gets wasted in all these computational devices, data centers, and whatever, everywhere, wherever electronics is. So people are looking for various ways of solving these issues, like there is a quest for room temperature superconductivity everywhere. And in the semiconductors area, there is a quest for finding semiconductors and magnetic devices, such as you can use some other things, such as the spin of an electron or some other magnetic moments of electrons. One is called Valley degree of freedom, which is also sort of a spin. It's a magnetic moment. So all these properties which we can use, if we can build some devices out of these, then we are able to overcome all these problems. Because by using other such as spins or Valley degrees of freedom and so on, which have recently come up, one can create dissipation-free devices. So one can, because the motion of some spin wave does not need to waste energy. It does not need motion of charge. Movement of charge is not needed. So the energy is not wasted. So in our lab, we are working with all these things. And we are putting them together. This problem we are trying to solve. And the method which we are using to understand all the physics inside all of this is, again, magneto-optical spectroscopy, high precision techniques which we have developed. And we are building them. We have built them actually already at IISER Pune with the help from various colleagues. And then there is a factory, very nice factory in Pune called 4VAC. Now these guys are good at precision machining. Unfortunately, in IISER Pune, we are still not very good at precision machining. There are machines, but human resources are still a problem for operating these machines. So we get it done from outside, and we have built some setups where we can do all kinds of optical spectroscopy, such as Raman, luminescence, absorption, reflectance, transmission, and so on, at low temperature, as a function of temperature, as a function of spatial resolution with a micron resolution or so, and so on. So in the magnetic fields, so Faraday rotation, Kerr rotation, so things like that. That's what we are progressing. Yeah.
Fantastic. So now, one of the other aspect which I would want to discuss is your outreach activities.
Yes.
One of the many things what you do, of course, apart from interacting with even school children and other things, is you have an online YouTube channel, which is a fantastic kind of initiative, which is called as India Science Theatre.
Yes.
Can you please tell us a little bit about that and the background behind that?
Yes. So, as soon as COVID started to happen, I found some time when I was in Germany. And that time I wanted to spend towards putting some efforts in improving science education in India somehow, because my main goal was to come back to India, of course, and I had decided. So I was like, why not just bring some people together who are of similar mind and who can, convey science which is accessible to public in their language. It's not only the language, the language in which we speak, it's also the language in which it's to be told.
Nice.
And these two things are very difficult to find in many scientists, to be honest. You find some people here and there who are able to do this nicely, but then to bring them together on the same platform, it becomes challenging. So what we did was, during this time, since people had already gotten very comfortable with Zoom and with online teaching and all these things, we built this online YouTube channel and a Facebook group called India Science Theatre. This Facebook group has grown into now 7,500 people.
Fantastic.
And India Science Theatre has around 1,500 subscribers, not much.
For science related activities, these are outstanding numbers. You should not go by conventional some other YouTube
the target is to reach millions.
No, the thing is that this is, I keep telling to a lot of people, including some other podcasters and other things. What happens is this effect is non-linear. A lot of these measures and metrics are only one part of it, because how much engagement you have. YouTube channels generally have only 5 seconds of views sometimes.
Correct.
And that they still add it as a view, right?
Yes.
But what is the engagement? You take, for example, some science channel which people are really engaged. In fact, the engagement probably would be even 1 minute. That is a big achievement compared to people who have 1 million subscribers or something like that.
Because it's fun but not for all, unfortunately.
Exactly. That's actually an important point. Continue, please continue.
So we started doing various activities together. We were a team of like 15 people. We still are. But the activity has reduced because of my challenges here in IISER Pune of building labs. So this team started various programs. For example, first program was initiated by me, where I told the story of atom in a series of 10 episodes.
Fantastic.
So this series was called Pucho Zara Pucho. The reason was, I had decided that I will produce various seasons on various things around science, but tell people in their own language and the way it has to be told. So I told the story of atom in this 10 episodes to someone who is not really from science, sitting in front of me, and I am just telling a story. And then the online audience would ask questions there in the comment section. And then we will, in the next episode, we will address those questions in the end of the episode and move on to the next and so on. So this is what I did. At the same time, I started doing one show in Punjabi language. It was called Science Da Mamla Hai.
Fantastic.
There is actually a song called Dil Da Mamla Hai. We created Science Da Mamla Hai by the name was provided actually by Arnab Bhattacharya, director of HBCS.
Who is also Chai and Wai.
I was associated with Chai and Wai also. His Chai quite long in TIFR. Arnab is not a Punjabi, but he knew this song. So he suggested this name. Very interesting. And then we did many episodes. Unfortunately, that program was off after a few episodes because the host moved. And then in this India Science Theatre, then we also started doing some online science quizzes where our team would come. The motive was not only to quiz, it was to learn. So what we did was we had maybe 10 or 15 questions, which we are asking live audience who are giving answers in Google, YouTube. It's program is live, so they are writing live answers, and whoever is the first person giving the correct answer out of those 100 playing or 200 playing, sometimes it used to be a lot. So then that person wins some prize, some cash prize, 250 or 500 or whatever. So this we used to give. But after every answer, we used to explain the science behind that in the language which is accessible. Now, the thing is, here you can use some technical words because people will keep on sticking there, hoping for the next question and hoping for some money. some reward. Engagement. So this engagement was done this way. We again, so this was quite successful until about a year back. We were producing one episode every month, or initially it was every 2 weeks and every month. So this was quite nice. And then regularly we were doing some show where we 4 or 5 people from science background who had done PhDs or postdocs and so on would come together and discuss some random topics, or just like we discuss on chai.
Nice.
So we were doing this live discussions and making jokes and laughing, just entering into scientists' lives during chai.
Yeah.
It was something like that. So this show was called for some reason Chand Ke Paar Chalo.
That's a good story for ISRO also. Probably now they've already reached.
Yeah, exactly. So this name was, I think, provided. I think this was invented by me, probably me and one Rahul Nigam.
Nice.
Mr. Rahul Nigam from Hyderabad.
Okay.
No, he is in BITS Pilani, Hyderabad campus. Yeah.
Nice.
There were some many other interesting people in this. You can check some episodes. And,
I'm going to actually link all these things in the show notes and the references.
Yeah.
The listeners can actually go and check that. Yeah.
And then I started a show called Magajmari, where I was again telling some story about some scientific problem or something interesting to a person from completely non-science background in a chilled out language.
Nice.
Like in a language in which friends are talking or whatever, like 15 minutes, 10 minutes or something like that. And the host there is someone called Neha Sharma, and she is a teacher of economics. So she has nothing to do with science. So it's a nice thing for me, because then it's challenging for me to also explain this to her in the way she would understand. So, but only 6 episodes there. And then I got super busy, extremely busy, because I had this huge pressure of bringing money for building lab. So I was just writing proposals after proposals after proposals, and outreach went, meaning online outreach went on a bit of back foot, but offline outreach I kept doing. With ISER Pune, there it's a science activity center, Ashok Rupner, and their team, Ankish Tilpude and their team, and so on. Amazing people. I mean, you look at their lab, it's a lab for kids, and you are super
That's
excited.
like, you go a kid in a candy store, right? You have everything. I get excited every time I go there.
Exactly. So whenever I'm bringing some kids or some friends from outside, I'm saying going to show you a magic show. It's that. It's magic with science.
Absolutely.
Lots and lots of toys. I use their toys for teaching also, undergrad, electrodynamics, and so on. But there they also keep on doing this online outreach activities, and I have done some shows with them also. Like one I did for James Webb Space Telescope when it sent the first images. One I did which was about magnetism and so on. 1 hour long shows, live shows, where the engagement is by the kids. There are like 500 kids online, and they are writing all the time their excitement and their questions and so on. And one also learns from this show, like the language in which the kids would talk. Like they would say, magnets OP. And what is OP? I learned later that in gaming terms, the OP is used for overpowered. So if some weapon is overpowered, it's OP. So everyone is like explanation OP, magnet OP. So these are these kids who are writing all of this.
Fantastic.
Yeah, so this is a lot of fun.
Amazing. That's fantastic.
Yeah, so, and then they would, so I would also go to sometimes some schools, or for example, next month I'm going to Symbiosis Institute for giving a lecture on sound, also on, these science days and so on, which we celebrate. I am doing some science show or science quiz we do with these kids. Like there are 2,000 people now, 2,000 kids playing science quiz live from science activity centers. So this is amazing. Like, they have these 80,000 subscribers, but during science show, this 2,000 people are playing together. It's challenging to maintain, to manage all of this.
Absolutely.
Because in YouTube, the comments would come within 1 second. There would be 50 comments when you ask a question there. and then someone has to be there to look
Yeah.
who was the first correct one and so on.
It's
Yeah.
a challenge.
Yeah.
Wonderful.
Yeah, so some things I keep doing. I
Right.
keep going to schools and I take this equipment from Science Activity Center actually, which is very, very useful.
Very, very useful.
Yeah.
Very useful. Absolutely right.
Yeah.
Absolutely. So now we are almost coming to the conclusion.
Yeah.
So of course, the listeners should know that this is part of something called as Emergence series, the conversations, what we are having. And Ashish will surely come back sometime again on Pratidhvani, and we're going to have a more elaborate discussion on specific topics, and more so with some particular focus on some questions related to the research, and which is biographical in nature again,
Yes.
in the way what you have learned and other things. So Ashish, also tell us a little bit about what is the kind of approach, let's say a student who is kind of getting started, especially at the research level, should take away from this particular kind of your experience. That would be good for anybody who wants to pursue experimental physics.
Yeah. So I mean, my only suggestion is like, do science if you love it, because this is only for those who actually love doing science, because the career in science is a bit different, quite different than other traditional careers. In the other traditional careers, you kickstart your career, say you start earning money or whatever, starting when you are like 22 or so on. But then, if that is exciting for you, fine. But if doing science is exciting for you, do it. Give your full dedication, full heart to it. And if you like to discuss science, that is one way to understand that you like it. If you like to be among people who do serious science and who like to discuss science, it's one other way to understand that you like it.
Yeah, one point maybe you want to also emphasize is that you can make a living out of it.
Yeah. And so what I was coming to that. So the thing is the following. I mean, I always tell people who say that you don't earn much after doing science and so on. No, that is not true. Of course, you are going to do a PhD first, and in the PhD there is some fellowship. You might feel like this is not enough, but that's only for that time. But at the same time, you are achieving something which others have not done. I mean, this is PhD. I mean, this is something which is huge.
Yes.
This doesn't come to everyone, and you are doing something which you enjoy. Now, these two things, they overcome every other challenges. On the other hand, you are living in some hostel and still living the student life, and that is something which is a reward. I mean, the longer you live as a student, the more rewarding it is. You keep on learning and so on, and the people around are fun and so on. But on the other hand, after a PhD, if you feel that you have done enough science already, because many people in Europe, I noticed, and also in India, that they feel that they have done enough science already and now they want to move to some other career. You are well equipped for many, many other careers. Now, in fact, you are better than many others who had started when you had started your PhD, because you have learned so much. You have learned how to tackle problems. You have learned programming skills, for example. You have learned instrumentation. You have learned, depending on what kind of field you are in. And you have been in a nice institute where there were some nice people around you, and you were trained subconsciously in a way to be a better human and to be a better at understanding issues of life, problems of life, and tackling them in a systematic way and so on, in a practical way, pragmatic way, which does not come otherwise if you do not have this experience. And that helps a lot, and this is what companies count on. Industry also counts on this experience that you have went through to give you some nice position. And these days for scientists, there are so many positions outside academics also. Now, I started it saying outside academics already because I noticed that about academics, people already have some sort of these opinions that it's a very long career and one starts to get quite old before one settles. The personal life is difficult. It's all true. I would not say it's not true. It's all true. But if you love to do what you are doing, if you love to think deep into the way nature works, and to think deep in understanding, to solving some challenges of nature or physics and so on, then it's a lot of personal satisfaction. It comes with a lot of reward, because whatever you produce is your baby.
Yeah.
Whatever you produce, you get immediate reward in terms of, getting sometimes some surprise reactions from many others in the community saying, oh wow, how did you achieve this? Oh wow, this is the way it works. So great. Oh, I did not even think about this. And all of this gives you an immense pleasure, and it keeps you going and keeps you going. And finally, when you are in academics, this is the life that you are going to be in. It's quite exciting. Very exciting. Yeah. The only condition is that one must be able to enjoy it.
Absolutely. In fact, these are all, extremely important words, what you just mentioned. That satisfaction aspect is sometimes underrated in the pace of the life.
Yes.
This sometimes doesn't get much emphasis.
Yes.
Because at the end of the day, if you go to sleep with satisfaction and you wake up with enthusiasm,
yes,
I think science gives you
perfectly put. I couldn't agree more.
Yeah. So Ashish, it has been an excellent discussion and conversation. In fact, as I mentioned, the making of an experimentalist is not a very kind of well-known story, and this is actually one of the very beautiful narration what we had now. And I'm hoping that people do listen to this aspect and get motivated. And second aspect is also to know what it is to become an experimentalist. That is something what you have beautifully defined. So I'm thankful to you for your time and your knowledge, what you have shared with us. And as I mentioned, this is part of the Emergence series in Pratidhvani, and I'll be very happy to have you back.
Sure. I'm always happy to talk. This is why we are doing science.
Absolutely.
We love to discuss. We love to talk and share our experiences.
Absolutely. It's been a pleasure, Ashish.
Thank you very much. Pleasure is all. Thank you very much.
So this is Pratidhvani, where we try to humanize science, and this time with an experimentalist, Ashish Arora.
Thank you, Pawan.